thanks again for inviting me to talk. I'm going to talk a little bit about an approach that I'm using to do fMRI-guided TMS, optimized by E-field modeling. If you're going to skip to the next slide, I have no disclosures. This is my current funding. If you want to go to the next slide, I'm going to talk today about targeting, and as we saw from the previous slides, it's important to consider both the location in terms of X, Y, and Z coordinates, but also the orientation of the coil when you're determining your targeting. And my argument is just that you need to have some sort of a systematic and objective way for accounting for all of these degrees of freedom. And so my approach has been an fMRI-guided E-field modeled optimization approach. So if you want to skip to the next slide, I can show you the basic outline of that. So the idea is that you first determine a theoretical a priori target, and then you operationally define this in M&I space in some way. So, I'm interested in anxiety cognition interactions. So I used a working memory target of the DLPFC, and then I had the individual subjects do the working memory task in the scanner, and I extracted the working memory related bold activity, extracted the peak, the peak of their working memory related bold activity. And then I used that as the site of stimulation. I conducted E-field models at orientations around that site, so adjusted the yaw orientation. And then I used the E-field model I used the orientation to optimize the E-field strength at that site of stimulation. Now, the takeaway from this is, at least for this part, if you skip to the next slide, you need to have some sort of an a priori definition of what your target is and sort of like what your target region is. Otherwise, the variability in single subject fMRI, and also it's likely the case the variability in single subject functional connectivity is going to increase the variability in your targeting. So in this little piece of data, I've just looked at the targeting across different definitions of the DLPFC. So I used an anatomical mask, functional mask based on working memory data from my lab, and then also a meta-analytic mask that I extracted from Neurosynth. And then I just compared that to an unconstrained approach. And if you skip to the next slide, what you can see is that any one of these a priori definitions of the DLPFC is going to increase the reliability of your single subject targets across subjects. So if you look at the distance between the targets, you can see that they're much sort of closer together when you use a region of interest to narrow your results. And it also keeps you a little bit closer to the surface of the cortex as well. So, and that's important for the next part. You want your target to be closer to the surface because that's where the E-field is strongest, and that's going to give you the most accurate. That's going to allow you to most accurately use the E-field models to optimize the stimulation. So if you skip to the next slide, some of the previous speakers have talked a lot about orientation, and what you can see from this animation here, the orientation not only affects the spatial distribution of the E-field model, but also the strength of the E-field at the site of stimulation. So it's important to consider both of these. In the next few slides, I'm going to talk just specifically about the strength of the E-field at the site of stimulation and whether or not this effect is strong enough for us to be able to detect it in a given sample, and by association, is this something that we should control for in our studies? So if you go to the next slide, what I did is I just looked, given a specific site of stimulation, I compared the optimal orientation to the suboptimal orientation across a set of subjects with data that I collected in the lab. And, obviously the optimal is going to be bigger than the suboptimal just by definition, but the question is how much bigger? And if you skip to the next slide, what you can see is that just comparing optimal to suboptimal orientation or maximally suboptimal, you get a Cohen's d of about 1.5. So, you get a fairly large effect in terms of the strength of the E-field at the optimal versus suboptimal. Now the question is, assuming that the magnitude of the E field at the site of stimulation is in some way predictive of behavior, how many subjects do we need to detect that sort of an effect? So I obviously don't have prospective data on this right now, but if you skip to the next slide, I did my best to sort of estimate what we might expect that effect to be using this equation. So you just take the Cohen's d of the difference in suboptimal to optimal orientation, and you multiply that by the R squared. So this is the variability in behavior that you can account for by the variability in E field magnitude at the site of stimulation. And that'll give you the sort of adjusted effect size that you can expect, the adjusted effect size of the E field strength at the site of stimulation on behavior. And if you skip to the next slide, I estimated how many subjects you might need given a set of hypothetical correlations between E field strength and behavior. And what you can see if you skip to the next slide, you can see that there's a decaying exponential function describing this. But if you have a correlation between behavior and E field strength of about 0.5 or greater, you can see an effect of orientation on behavior in a sample size that is appropriate for sort of what we've been doing in clinical trials. So, 100, less than 100 per group. What I want to do next is, rather than estimating the correlation between E field and behavior, I'd like to do a study where I can experimentally manipulate this. So again, using coil orientation as a way to experimentally manipulate E field strength, what I'd like to do is compare an optimal to a suboptimal group using fMRI-guided TMS to see if I can observe a difference in behavior based on coil orientation. So it's currently under review. We'll see what happens. If you skip to the next slide, that's all I got. Hopefully I'm within close to my 5 minutes. Thank you all for listening to me talk, and my email's on the slide if you have any questions.